Alright, today we're going to talk about the Pythagorean theorem. We're going to focus on word problems, which is 90% of the time when you take a test on this, word problems are what they're going to be on. This is on not only your state Algebra 1 test, it will also be on the ACT. So, first thing we have, Justin and Selena measure the soccer field. The soccer field is a rectangle, 90 meters wide and 120 meters long. The coach asked them to run from one corner to the corner diagonally across the field. How far did Justin and Selena run? So your best bet for all of these is going to be to draw a picture, just so you can visualize it. So first of all, we have a rectangle. There's my soccer field. Okay, it tells us it's 90 meters wide and 120 meters long. They are running from one corner to the corner diagonally across the field. So it doesn't matter whether you run from here to here or the other way. I'm just going to go from here to here. We're still trying to find the diagonal distance. Okay, remember that's the hypotenuse. That's the one we don't know. So you're going to have to remember your formula. A squared plus B squared equals C squared. Your A and B values are your legs. If it helps you to transfer this leg over to this side, that's fine. So remember, it doesn't matter here. 120 can be A or 90 can be A. I'm just going to use 120. So that's 120 squared plus 90 squared, and that's going to equal C squared. Remember, we're going to evaluate these and add them, and then we're going to take the square root. Now, a shortcut that you may want to use instead of finding what they are and then going back and square root them is in your calculator. If you actually do the square root of 120 squared plus 90 squared, that will get you straight to the C value. It doesn't matter to me which way you do it. You can square them, add them, and then find the square root. But since you are using the computer on Desmos as a calculator, if you're still using that, D-E-S-M-O-S, or I know some of you are using your cell phones, or whatever's the easiest for you. So I'm going to shortcut and use the shortcut. So the square root of 120 squared plus 90 squared gives me my diagonal length here, which is 150. Sorry, my pen's going crazy. 150 meters. Maybe. 150 meters. Meters somewhere. Okay, don't judge the handwriting. 150 meters. So now, since this is a word problem, you're going to need to write your answer out in words. You cannot just put 150 meters. That does not answer the question. The question is asking, how far do Justin and Selena run? So your answer needs to be in words. It needs to be, Justin and Selena run 150 meters. So if it's a word problem, you need a word answer every single time. Make sure you're putting those units. You know I'm petty and I will count off with no units. Make sure it's a complete sentence. If you put 150 meters and put a period at the end of it, that does not count as a sentence. So Justin and Selena run 150 meters. You can even be more specific if you want to say Justin and Selena run 150 meters diagonally across the field, or from corner to corner diagonally across the field. Whatever you want, just as long as you have at least that much information. All right, next we have Heather and Heidi's mom wants them to paint the house while they are out of school. They need to decide how far up the house a 12-foot long ladder will reach if they place it 3 feet from the wall. How far up the house will the ladder reach? So do the same thing. Draw a picture. Okay, we're using a ladder. Remember, this is not one of those ladders that fold open into an A shape. This is a straight ladder, okay, kind of like an old school ladder, one that reaches very high, kind of like what you see on top of a fire truck. So the ladder is going to be diagonal. Here's my ladder. Okay, pretend it's straighter than that. It's a little crooked. It is a 12-foot long ladder. That's the measurement here, 12 feet. That's how long my ladder is. It's leaning up against the house. The other information is that it's 3 feet from the wall. That would be here on the base, 3 feet. So now I'm looking for how high it will reach up on the house. This is the house. This whole part here is all of the house. So if I think about the Pythagorean theorem, a squared plus b squared equals c squared, I have a leg, and this right here, since it's across from my right angle, This is my C value. So that changes this formula. So now I will put 3 squared plus B squared, because I don't know this, okay, this is my unknown, equals 12 squared. Now I will evaluate these. So this is 9 plus B squared equals 144. You shouldn't have to put these in your calculator anymore. To solve for B, I will subtract 9 from both sides, and I have B squared equals 135. So now to solve for B, I will take the square root of both sides. Now remember how on the first one there was a shortcut? On this one there is a shortcut. Since I'm finding my leg, I'm finding a leg, my shortcut is to take your C squared value and subtract your A squared underneath the square root. So here I could do the square root of, my C squared was 12 squared, minus 3 squared, put that in the calculator just like that, and it will tell you that my B value is about, let's round to the nearest hundredth, 11.62, and I do need my unit here. This is feet. So 11.62 feet. And remember, when we're estimating or when we're rounding, we could change that equal to the squiggly. Remember, that means approximately or about. So let's go ahead and round to the nearest hundredth on all of these. Now remember, I'm not done, okay? I'm not done because I have a word problem. I need a word answer. So my word answer is, the ladder will reach up 11.62 feet on the house. So now when Heather and Heidi are painting, they know they can get a little if their house is 12 foot tall, if the ladder is reaching 11.62 with their arm length, they should be able to paint their 12-foot house. If their house is taller, they're going to have to figure out another method. So they can at least get 12 foot high painted on the house. All right, let's move on. Xavier and Cameron are not following the rules of social distancing, shock face, and they go to the baseball field near where they live. They measure the field, they measure the field X and find that the baseball diamond is a square that is 90 feet on each side. If Xavier throws the ball from third base to first base, how far will the ball travel? Now, I've seen this test on the ACT. I've seen it on many state tests. They love to use the baseball field or softball field example for Pythagorean theorem because it's something most people can relate to. So they said it was a diamond in the shape of a square. That just means that all four sides are equal. So we know it's 90 feet on each side, and this is the real dimensions of a baseball field. Okay, softball field would be a little shorter. I think it's 60 or 65 feet. So 90 feet on all four sides. Xavier is throwing the ball from third base to first base. So if you're not sure, this is home. Going counterclockwise, we have first base, second base, and third base. So he is actually standing on this base and throwing straight across. If you notice, that makes your right triangle. Okay, right here is your right triangle. And you could look at the bottom portion too. So here you have to decide whether we're missing legs or the hypotenuse. Since we're missing the length across from the right angle, that means we're missing our hypotenuse. So we have 90 squared plus 90 squared, because those are both my legs, A and B. I'm going to use the shortcut here, the square root of 90 squared plus 90 squared. I'll put that into my phone or my calculator. Let's still round to the nearest hundredth. Okay, so rounded to the nearest hundredth would be about 127.28 feet. So that's why you want a third baseman with a really strong arm, because they are throwing the furthest distance. They're throwing diagonally across from third to first. That's about 127 feet. Same way why your catcher has to have a really strong arm, because they have to make the throw to second base often if somebody's trying to steal from first, and have to throw about 127 feet. So this is real life, okay? I'm not saying that people would go out and say, oh, I could throw 127 feet. No, but when we make baseball fields, we have to take those dimensions into account. If it's not that, then the field is not set up right and other teams could contest a win and stuff like that. So it is important to real life when we're designing these fields and we're building them. Remember, this is a word problem, so you need a word answer. So the answer is Xavier throws the ball 127.28 feet. And you could add to that and you could say from third base to first base. Alright, Denasia and Ari decided to fly a kite. Ari let out 650 feet of the string and held it. Then Denasia walked 600 feet away from Ari till the kite was directly above her head. How high was the kite from the ground? So here's Ari. Okay, remember she's short. Ari's holding the kite string. She let out 650 feet of the string. Here's the kite. I can't really draw a kite. There we go. Ooh, that wasn't bad. Now, Denasia walked 600 feet, so let's just pretend this is like exact here. We're not taking their heights into account. 600 feet away from Ari, directly below the kite. Here's Denasia here. We want to know how high is the kite. So since we're missing the hypotenuse, we're not missing the hypotenuse. I have the hypotenuse. I'm missing a leg. I'm going to use the shortcut, the hypotenuse squared minus a leg squared. And that's going to take me right to my C value there, which is exactly 250 feet. So that's it there. This is exact, no rounding needed. So the kite is 250 feet up in the air. So if you're not sure, you might have to sometimes draw a couple pictures to make sure you're getting it right, you're visualizing it right. But remember, word answer here, the kite is 250 feet high, or 5 feet high up in the air. Lane and Alina decided to set up a zip line over Lane's pool. Please do not try this at home as an example. The platform at the top of the zip line is 25 feet tall, and the zip line is 40 feet away from the edge of the pool. So platform, it's up in the air. Here's my platform. It's 25 feet tall. The edge of the platform, or the zip line, is 40 feet away from the pool. So this would then be the pool here, pool. We don't really know how long it is, but that doesn't matter here. So we're trying to figure out what is the minimum length needed for the zip line. So they're going to zip line diagonally. Here I'm missing my diagonal length across from the right angle. That means I'm missing my hypotenuse. I have my legs A and B. So I will have 25 squared plus 40 squared equals my C value. So when I put this into my calculator or my phone, whatever, and remember the order doesn't matter here. This can be 40 squared plus 25 squared. I get about approximately 47.17 feet. Now, I do want you to visualize this. If you are zip lining, okay, here you are, you're zip lining, coming down. I'm not going to say who's going to zip line first. We'll probably make Gabe or somebody go first, or Will. They're going to zip line. If they land here, they are not in the pool. They are on the edge of the pool. So that means they'll be a little bit short. So let's go ahead and play this safe, and let's just round this up. Go a couple feet over so they actually land in the pool. You might want to say 50 feet or 55 feet or something to that manner. Okay, even though that 47.17 feet is the minimum, let's add a little bit there just to be safe for everybody. Remember, this is an example. So I'm going to say the minimum length needed for the zip line is 50 feet. Okay, most of Lane and Alina's friends are really short. Any other tall friends? I don't know. Just do the best you can. Tuck your feet up. Alright, last but not least, Lillian and Sarah are both buying new TVs to put in their rooms. The dimensions of the TV that they want to buy is 30 inches by 40 inches. So remember, dimensions, that would be length and width. 30 inches, 40 inches. Remember, I told you last week that TVs are measured diagonally. So when they advertise it, they measure diagonally. That means I'm looking, once again, for my hypotenuse. I can use my shortcut. 30 squared plus 40 squared equals my C value. That means my C value would equal 50 inches. So if they were selling this TV on the box, it would say a 50-inch TV. That's how they sell it. Does it mean it's 50 inches wide? No, it means 50 inches diagonally. So the diagonal length of the TV